Welcome to the NetNumber Power Hour session. Douglas Rinaldi is the founder and chief strategy officer of NetNumber Inc., a leading provider of signaling control technology to the global communications industry. Mr. Rinaldi is a serial entrepreneur, having created 3 successful startup businesses in his career. He is the author of 6 communications-related patents and is the subject of several case studies developed by the Harvard Business School that are utilized by MBA programs around the world. Mr. Rinaldi holds an engineering degree from Cornell University and an MBA from Harvard. Please welcome Douglas Rinaldi to the stage.
Thank you, Kim. Good morning, everyone. I appreciate your determination. 4 days at the Mobile World Congress, no sleep, very little food, lots of coffee. We're coming to the end. In this hour, what I hope to do is give you more background information about the signaling core network than you could ever want to know, and give you a path forward for how to simplify that core network to improve the efficiency of all of your organizations. Within the industry today, we see 3 major trends that create challenges for us. Of course, we also see opportunity, but with the opportunity come challenges. First, cost. All the operators that we deal with are under cost pressure. First, in general, we're dealing with declining average revenue per user on a global basis at a time when costs are rising, both OpEx and CapEx. Now, why are costs rising? They're rising because of complexity. We're under constant pressure as an industry to evolve our infrastructure to deliver faster bandwidth, faster connection, faster downloads, more services. Today, we're investing in LTE, we're investing in IMS, we're investing in IoT. At the same time, we're moving through a technology transformation as we try to re-envision our networks in the form of a virtualized infrastructure and a cloud service. So within that context, where can we look for good news? I want you to look to the signaling core. And of course, by the end of today, I promise you, you're going to know everything about the signaling core. Before we get into specific details, let's talk for a moment about, at the high level, what's the opportunity here to improve the network? First, we see an opportunity for massive cost savings. I'm not talking about 10% cost savings. I'm talking about cutting the cost of the signaling network by 80%. So this is not a small issue. Second, faster service innovation. Today, if you dig into your network and look at how your signaling network functions, you're going to find it's almost impossible to introduce change. Now, that's almost unfair when you consider OTT providers that the industry competes with change their services on a moment's notice. So in order to participate in this world, we have to find ways to innovate faster. In signaling control, we can improve this. And finally, we can enable the signaling control network to scale to support the Internet of Things. At a very basic level, the networks that we're running today were designed by very smart engineers anticipating human beings are using the network. Human beings are paying $50 a month for a wide range of services. And so we built the network to accomplish that goal. The Internet of Things changes all those assumptions. No longer human, no longer a wide range of features. Now we're talking about an explosion of small devices with very narrow functional requirements. The same smart engineers that built the network we have today would totally redesign the network for IoT. And I think as you anticipate, that's what's going to occur. So first, what is signaling control? 3 basic functions that occur in your network. Routing of signaling messages. As an industry, we love to reinvent ourselves. So signaling control isn't just one type of message. It's many types of messages. SS7 messages, so we need to route them. We need an SS7 router. In the signaling network, that's called an STP. Diameter messages, we need a diameter router. It's called a DSC. HTTP messages, we're just introducing standardized HTTP access to the network. Today we call that a UT proxy. SIP messages, the whole IMS core is based around movement of SIP messages. We have multiple SIP routing proxies or routers in the network today. You know them as the ISCSCF, BGCF, or CRE. So we route signaling messages. One of the purposes of routing those messages is to gain access to network data. Subscriber data. If you're talking about an LTE network or an IMS network, subscriber data sits in an HSS. In a 3G network, subscriber data sits in an HLR. Both of those services, those databases, utilize subscriber authentication data that sits in an authentication center. And if someone steals your phone, it's got to be published somewhere, sits in an EIR database. There's also routing data that encompasses number portability, subscriber location functions, least cost routing, and policy data sits in the PCRF today. Finally, signaling control addresses a very specific firewall functionality. Signaling networks today come from a history where there used to be a relatively small number of trusted carriers on the planet. So when we built signaling networks, we designed them to exist inside a trusted network. We just didn't anticipate the same type of firewall requirements that are so common in the IP network. As we've continued to evolve, we've introduced direct connectivity to virtual network operators. We've introduced connectivity to OTT players. As we've expanded access to the network to a broader group, what we're finding is we have to firewall all of these signaling services. And when I say firewall, I don't actually mean block access. What I mean is identify inappropriate use. The people that get access to these networks are in fact trusted, but that doesn't mean they use them correctly. And you've got to have ways to find HTTP messages that you don't want to support, SS7 messages you don't want to support, diameter messages you don't want to support. That function exists in signaling control. Okay, let's take a look at the Converged core network. It's complicated, it's costly, and it's not ready for NFV scale. So after 15 years of hard work in the standards bodies, we've, one step at a time, evolved to a really complicated standardized network. I'm sure all of you have seen various versions of this diagram. Believe it or not, you could actually make it more complicated than this. I made some simplifying assumptions. If you look in the lower left corner, you see the evolved packet core. It's just one little spot. You could explode that all on its own, and it's remarkably complicated. Now, as a carrier, if you actually build your network following this standardized structure, you're going to end up with a very complicated infrastructure. Now, I think when we first started this, we really envisioned it wasn't going to be this messy. A couple things came along that caused us to make it more complicated. So let's just talk for a second about, why that is. We make it complicated because we actually do get benefits. First, we want multiple technology vendors. Service providers found that if they allowed their network to be designed by a single technology vendor, what happened is costs were higher than expected, change was slow, and innovation was limited to one vendor. So we decided to introduce a standardized architecture. The benefit we get, many different vendors can deliver all of those standardized functions from the previous page. So you get flexibility. The complexity we get is the end result of that flexibility. Second feature that drove complexity is that we wanted to support multiple networks. Probably if you asked anyone in a telecommunications industry 20 years ago, if you asked them, when would the circuit switched network go away? You'd hear words like, it'll be gone in 5 years. We've been hearing those words. Every 5 years, the answer is the same. It's going to be gone in 5 years. It's going to be gone in another 5 years. I heard a startling statistic the other day. On a global basis, circuit-switched SS7 traffic won't peak until 2018. It's actually still growing. But no doubt, it'll be gone in 5 years. We don't believe that anymore. So what do we have? We evolved our standards to allow us to live with multiple types of networks in parallel. So we have the circuit switch network. In the mobile world, we have 2G, 3G, 4G, soon to be 5G. The standards wonderfully allow us to support that. The trade-off is, it's complicated. So, as an industry, it's worth asking the question, can we keep the benefits of this complexity, but skip some of the trade-offs? So, signaling control. This diagram narrows your focus a bit. The green boxes represent everything in the standardized architecture that's defined as signaling control. Let me just walk through a few of these, give you a few use cases so you can orient yourself to the picture. Down in the bottom left corner, you see radio access network and the evolved packet core. So imagine you're a user, you turn on your smartphone, reaches out over the radio network, tries to establish IP connectivity. That connection is established between your phone and the evolved packet core. Now, before the Evolved Packet Core is going to honor your request, has to do several things. First, who are you? It's got to authenticate you. Signaling control messages, in this case diameter, go from the Evolved Packet Core up to the HSS and the Authentication Center in order to answer a simple question. Do I know who you are and do I trust you? It's actually a series of messages that are used to accomplish that magic, all diameter, all of which have to be routed through a diameter signaling controller up to the correct HSS, correct AUC, and then you get accepted into the network. Once you're accepted into the network, your location has to be updated. That's updated into the HSS. And the policy that you've signed up for has to be applied. So a session needs to be established to the PCRF, a binding, so that while you're connected to the network, whatever policies are tied to your billing plan actually get honored. So those are examples of very practical things that generate signaling control messages, and that's just connecting to an LTE network for data. That's all we've accomplished. Great thing, but it's just one step. Now, of course, if you want to gain access to services, like a voice service or a messaging service, you've got to register for those services. That happens behind the scenes through what we call the IMS core. You see that in the center of the picture. There are enough steps in there. I'm not going to walk you through those particular details. But in the IMS core, SIP messages and diameter messages connect you to the correct application server and allow you to gain access to common services that we're used to. The ability to send or receive a phone call, text messaging. And then finally, over on the right-hand side, you see interconnection to the rest of the world. Because you don't want to just talk within your own single network. You've got to interconnect. You've got to interconnect to other circuit switch networks. That goes out through the media gateway control function. You've got to interconnect with other SIP networks or IP networks. That happens through the IBCF, a fancy name for an egress SBC. From NetNumber's perspective, looking at this problem, we asked ourselves one essential question. What would happen if you thought about signaling control as a single problem? I understand the value of these standardized functions, but when you actually go to deploy those standardized functions, do you really have to deploy standalone PCRF infrastructure where you have to deploy it, integrate it, scale it, monitor it, upgrade it? Then separately, a DSC infrastructure from a different vendor. Purchase it, integrate it, deploy it, scale it, monitor it, upgrade it, separate from your HSS. The truth is, that is what we've been doing. Signaling control is complex and expensive because we treat every one of these functions as a separate infrastructure in the network. Not just a separate function, but an actual separate infrastructure with a staff that manages that infrastructure. So NetNumber's innovation to this space was to say, let's keep the functions. Let's keep the standard interfaces. But you should deploy those functions in one infrastructure. So all you do is you deploy a signaling control infrastructure. You scale your signaling control infrastructure. You monitor your signaling control infrastructure. You don't have to do that for 15 functions. You do it for one network infrastructure. You just happen to utilize it for 15 functions. Totally different way of thinking about the problem. But what does that produce? It produces a dramatically simplified architecture. All the boxes from the previous page still exist. What we did was collapsed those 15 signaling control functions, and they exist inside the Titan CSRC. Diane Myers from Infonetics, one of the key industry analysts in our space, coined this phrase, CSRC, Common Signaling Routing Control Platform. Trying to work to help the industry understand this isn't a case of one vendor proposing an idea. This is actually a structural shift in the way you should think about your signaling control network. You still have to have the network, but you should build it inside one infrastructure, not 15 infrastructures. Now, I'm going to walk through this a little bit. Remember the use case I talked about with you turn your smartphone on and you want to connect to the network for data access. All that functionality still exists. Down in the lower left corner, you turn on your phone, reaches out of the radio access network, establishes a connection to the Evolved Packet Core, and now the Evolved Packet Core needs to ask several questions. Can I authenticate you? So where does it go? It goes to your signaling control infrastructure, that's CSRC. That's all it has to do. Send the diameter message to the CSRC. Inside the CSRC is the diameter signaling controller, the HSS, the AUC, the PCRF, the subscriber location function. All of those functions are necessary to just connect you to the network for data. But by treating them as one infrastructure, anyone can learn to manage this. And when you narrow the scope of the complexity, a broader range of people in the industry can understand it, broader range of people can work with it, and as I walk through the details, you'll see it'll actually scale. Now, a couple of questions that we get when we present that picture. Who doesn't like that picture? Why would you possibly live with a mess if alternatively you could have one simple, elegant solution? Everybody, of course, would say yes. So, seems so obvious, but there are some tough questions to ask. First, let's look at NFV. Lots of discussion today around how NFV is going to make things so much easier. So, I'm a big believer of NFV. I believe that signaling control should all be virtualized. But if we take the 15 physical silos that we run today, and we just take those silos and we deploy them in NFV, you're going to keep the exact same chaos. You're actually going to increase your costs. You're actually going to spend money to retrain your staff, to live with the mess in a new deployment architecture. You didn't gain anything. Great quote. I was at one of the industry conferences last year. Key executive from Deutsche Telekom, was up talking about NFV, and I had to capture his quote. It was just great. He said, "Chaos, when virtualized, is still chaos." This is absolutely true. It doesn't mean NFV is bad. NFV is wonderful for removing the complexity of managing physical assets in the network. So we're going to do it. This is the perfect time, though, to re-envision how do you remove complexity from your infrastructure when you move to NFV. So, next question. How does the CSRC reduce cost? I mean, don't I have to buy all of this stuff anyways? I just told you the 15 functions are actually necessary. You can't connect to the network without them. You can't send a call without them. We're not eliminating any of those functions. So then why would it possibly save any money? First, you got the software licensing cost. In truth, there's no difference. You're going to pay whatever the market price is for diameter signaling control software. You're going to pay that price. It's a competitive market. It's a standardized function. The vendors are all fighting for your business. So you're not going to change the price of the software. But the software itself is a tiny fraction of the cost of the infrastructure. At least 10 times the cost goes into living with every piece of software that you deploy as a separate infrastructure. And when we talk about going to a software solution, you really should get some benefit. Here's where we can achieve it. In today's world, there's a team of people that integrates each of those 15 functions. And the team that specializes in the diameter signaling controller typically knows nothing about the STP or the HSS or the ICSCF. You actually have to have separate teams of people. The teams that operate them are different. They all have to be integrated into network management. They all have to be upgraded. They all have to be scaled. The RFP that you issue to license the software is the smallest part of the equation. So the power here is get rid of all of the operating costs. And I said, this is not minor. This is a massive shift in resources, costs out of the network, because you don't manage 15 infrastructures. You manage one infrastructure, it just happens to do 15 things. That's cost. I also mentioned that moving to this model enables innovation. I contend here the key is it's no longer risky to test ideas. So, innovation, by definition means change. Someone in the marketing group comes up with a great idea and says, I know customers are going to like this. Now remember, in the internet world, when someone comes up with a good idea, what do? They slap it together as quickly as possible, and they stick it out in the market, and they test, and they get quick feedback. And if it doesn't work, they kill it. But we don't do that in carrier networks. We never do that. Why don't we do that? We don't do it because it's too costly. Because if you come up with this idea, and then you get the network architects in the room and you say, I want to implement the idea. Every time you find that you need to make a change to 5 different functions. But those 5 functions are all separate infrastructures. They all have separate release roadmaps. They all have separate timing for upgrades. So now the executives say, okay, that sounds like a good idea, but it's going to take 2 years and an enormous amount of money to align those 5 roadmaps, make those software changes so that we can start testing. Are you absolutely sure this is going to work? Because we're not going to do it unless you're sure it's billions of dollars. In truth, absolutely certain billion-dollar opportunities don't come around very often. We stumble upon them through innovation. But as an industry, if we don't allow that innovation because the core is too confusing, we're never going to innovate. In the CSRC, you have only got one spot to focus. Now, NetNumber is a company. We are a vendor of a CSRC. In our approach, when we looked at this problem, we addressed it with what we think are 2 key aspects of flexibility. The first is in the database. Whenever you come up with a new idea, it almost always means you have to make some change to data. There's some feature of a subscriber profile that nobody had thought of. So you actually have to change the database. What did we do? We decided to make the database schema-driven, which means you could change the schema anytime. You don't have to wait for a software upgrade. We don't want you to wait for a software upgrade. Don't pay us the money. What we want you to do is innovate and pay nothing to the CSRC vendor. So that's on the data. The second is true in the logic. Of course, this is a new idea. The network has to do something it didn't do before. So you've got to be able to add new logic. Now, if you come up with an idea and the answer is always, well, you got to come back to NetNumber and align with a roadmap and pay the upfront cost, you're not going to do it. So what did we do? We gave you the tools to build and test your own service logic. You don't have to pay us. Next issue. How does the CSRC help in IoT scaling? What we've seen is that we can achieve a greater than 50% reduction in actual signaling traffic. So let's go through the use case I discussed earlier. LTE authentication. User comes into the network, they turn on their phone. First thing that happens is a device in the Evolved Packet Core called the MME, Mobility Management Entity, sends a message up to the authentication center to ask a simple question. Can you authenticate this user? So a diameter message goes from the MME to the DSC, to the HSS, to the UDR, to the authentication center, and then it comes all the way back. And that's for one message. There are many messages just to accomplish this feat. So you've heard in the industry that we suffer from an explosion of signaling, a signaling storm. Here is your practical reality. It is a signaling storm, because we take one simple request and look how many messages we turn it into. Every one of those arrows represents a network hop. 5 milliseconds, 10 milliseconds, depending on how far you have to go. Don't do it that way. Take the DSC function, the HSS function, the UDR function, the authentication center function, deploy them in one infrastructure. No more signaling in between those things. The message traverses the core, actually traverses the server that you sit on all on its own. No more network path to achieve that. So the messaging, in fact, does occur. It just never traverses the network. So you go from 10 milliseconds to 1 or 2 microseconds. 1,000-fold reduction in the actual cost of that signaling flow. So you could either have 6 network hops per action, or in this particular use case, 2 network hops. We're being conservative when we say 50% reduction. In the end, it's going to be greater than 50% reduction. And so the system will, in fact, scale. Not only are we eliminating work, we're speeding it up, and by definition, enabling it to scale. And that's necessary if we want to realize a truly connected vision. So next question we get, can I deploy in stages? Because if you start to get excited about this idea, first thing you do is you go back and look at your network and you realize, I've already got all 15 of those functions. I have the mess today. So do I really have to do a project where I eliminate the whole thing and I switch to the CSRC? Seems insanely risky. So of course the answer is no. That would be practically impossible. Here we get the benefit of the standardization process. All of those 15 functions that you've got today, they have standardized interfaces. So what you can do is you take the next RFP. Let's say you have an RFP for replacing an end-of-life STP. Here's a great fork in the road. You could either buy a new standalone STP and repeat the pain of the past. Life will never get better. Or you could say, hold on, maybe I should do something less complicated. Let's put in the CSRC, and the first application we'll enable is the STP. Now, you've solved that RFP, but what you've got is a platform so that your next RFP, let's say you have a problem with or first time you want to introduce a diameter signaling controller. You don't have to put out a new infrastructure. You could just turn on the application in your CSRC. So you can see how if you start one step at a time, you can collapse the functionality into the CSRC, drive cost out of your network. Every single day, it gets better. The CSRC drives cost out of the network, accelerates innovation, eliminates internal signaling. So, kind of one of the things our sales guys love to do at this point in the presentation, they'll pull out their smartphone and they'll say, well, I mean, why is this thing so powerful? It's powerful because on that one device, you get multiple apps. Imagine how crazy it would be if you had to have a separate phone for every function. You had to have your phone because you wanted the Hertz application, and a separate phone for access to news, and a separate phone for calling. I mean, it's completely stupid, right? This is what we've been doing as an industry in signaling control. We've been carrying around 15 phones in our pocket. This is a huge mistake, and we should stop it. So, the CSRC, a common signaling platform, you integrate it once. You learn how to run it one time. It's only one thing to operate, one thing to scale, one thing to virtualize. But you get to use it for 15 different functions, just like your iPhone. And it's going to cut your signaling traffic more than in half. Your costs go down, you can innovate quickly, and the network will actually scale to support the Internet of Things. With that, I'd like to stop, see if you guys have any questions for me. Now, typically, I find you're not willing to ask questions. You look at that complexity of that architecture diagram, and you say, I'm not willing to do it. But I always like to ask, guys, any questions? It's a small group. We promise, no matter how foolish, it won't go outside this group. Okay, look, that doesn't surprise me. I greatly appreciate your time. It's Thursday. We're coming to the end of Mobile World Congress. Thank you very much for your time and attention. If you'd like more information about what we do at NetNumber, come visit us in Hall 7, and we're right across from the burger joint. Thank you very much, guys. Thank you.